Good afternoon and good evening, everyone. It is 6 o'clock in Central Europe, and I'm really proud and happy to welcome you all to our Erc Research Net session at the Virtual Resuscitation 2020. A cordial welcome to everyone. My name is Bernd Böttiger. I'm currently the treasurer of the European Resuscitation Council, and I have been since a few weeks ago the ERC Director Science and Research since the beginning of this position, some 8 years ago. I was not able to stay longer in this position according to the bylaws of the ERC, and I'm nevertheless happy to chair this session today together with Charles Deacon, who is joining us from Southampton. Charles.
Yeah, good afternoon, everyone, or good morning or good evening, depending on where you are. I'd just like to reiterate Bernd's warm words of welcome to you all. It's very unusual, of course, in terms of the Zoom setup, but I think the sessions have been working quite well so far, and we'd encourage you all to try and interact via the chat function and with questions that we'll try and moderate off the end of each speaker. So we really do want to make this interactive and hear from you, your thoughts and comments. So please do feel free to feed back to us via the chat function at the side of your screen there. But we're looking forward to a great session. For those of you who don't know me, I know most of you, I think, but I've been involved with the ERC almost as long as Bernd, and I've really worked on the ALS side, both in terms of chairing the ERC ALS committee, of which I'm still a member, and I've been on the board of the ERC for a good 10 years or so. So it's an honour to be here and assist Bernd in terms of steering us through the meeting.
Thank you very much, Charles. And as Charles pointed out, we have several presentations today. For all this, we have 90 minutes, and we can take these 90 minutes. We have asked all the speakers today to stay for 5 minutes with their brief presentations so that we have 3 or 4 minutes time for discussions in each presentation. And as with all other sessions during this virtual ERC conference, longer presentations from each topic and from each speaker are available down here and in the internet. So this is the first time we are doing the ERC Research Net session virtually, which is something special, but it is because of the Corona crisis. We all know this. And so far we had a very excellent program and excellent sessions, and I'm sure that we will have another one right now. I would just briefly introduce the ERC Research Net, which has been established by the European Resuscitation Council in 2013 in Krakow. So in the meantime, we can be very proud that we have more than 200 members. We have a lot of studies ongoing and already published. Some of them, we will see this very soon, are funded by the European Union, which is some work to achieve. We have in the meantime, and just today, I have received 4 of them and sent them out to the Research Net. We have more than 50 high-ranked publications in the meantime out of this collaboration. It is really an outstanding success, I would say, with more than 250 impact factors overall. We are also doing the ERC Research Net Summer School, as you know, and more or less all of the people I can see on the screen right now here have joined the ERC Summer School over the last years. This year it was planned in beautiful Italy at the Lago di Garda, but unfortunately we have to postpone it, and hopefully we can do it next year in beautiful Italy. Today we have some important impressions from the ERC Research Net. It is only some few of many, and it is my great pleasure to introduce as the first speaker Hanno Tan. Hanno Tan is a leading cardiologist from the Amsterdam Medical Center. He is the principal investigator of the EU-funded ESCAPE-NET project, He's an expert in large-scale studies on genomics. And by the way, he's a very nice person. And Hanno Tan, please give us your presentation now on ESCAPE-Net, the most important results from a European Union Commission-funded multinational project on cardiac arrest and CPR. Welcome. We are very much looking forward to your presentation now.
Thank you very much, Bernd, for your very, very kind words. Well, I share the feeling of being very happy to work with all of you, with you in particular, of course, Bernd, but with everybody else. And I'm also very happy for the opportunity to be able to share some of my experiences and my views on the work that we have been doing together. So yes, it's only a very brief outline of the work that we have been doing. So the ESCAPE-Net, as Bernd said, is a Horizon-funded project. It's a 5-year project, and it's a bit over halfway through now. This is the title that you can see here. This is what ESCAPE-Net stands for. More importantly, I'd like to point out that ESCAPE-Net tries to cover the field of sudden cardiac arrest science in as broad as possible way that is relevant for a clinical application. And we have more or less defined 2 basic pillars of the whole project that you can see here. On the left is the pillar which deals with trying to understand what causes sudden cardiac arrest. As you all know, the causes of sudden cardiac arrest, of the arrhythmias that underlie it, are very, very very numerous and also very complex. They range from inherited factors, genetic factors, for instance, to acquired factors. But they also include other factors such as socioeconomic factors, environmental factors. So it's a very complex issue, a very challenging one, but an issue that interests us in its whole breadth. So what we try to do is try to understand what causes it and try to build on that to design preventative strategies for the future. Now, the other main pillar is the one that probably interests you even more, which is the resuscitation science, trying to understand what treatments for sudden cardiac arrest, out-of-hospital cardiac arrest work best. And so with all this, both these ambitions, it is, I think, quite clear that the key issue that needs to be resolved is getting the good data sets, obviously, very high quality data sets, but also very large data sets. And this is where ESCAPE-Net comes in, because we have been able in ESCAPE-Net to combine the efforts of 16 partners across Europe. The ERC is one of the partners. The ERA, European Heart Rhythm Association, is another partner. But in addition to that, we have many partners who actually contribute patient data, patient cohorts, and also DNA samples. And we have been working and succeeded in harmonizing these data to enter them into one harmonized large data set. And by large, I mean that we have in that data set more than 90,000 sudden cardiac arrest victims and almost 15,000 DNA samples of sudden cardiac arrest victims. So this is where the actual work starts, one could say. And the next slide, please. So the so we are a little bit over halfway through, and we have been fortunate enough to be able to publish already some papers, quite a few, in fact. And we have still 49. We have still, well, over 50 other research projects going on. We organize them in the research proposals that can be submitted to the steering committee of ESCAPE-Net. And there are several types of research activities going on, including controlled trials, such as the AMSA trial that's going on in Bologna and in Milano, and also in Finland, and where Federico and Andrea are much involved in. But this is just one example. I'm also very happy to say that this also has led already to some spin-offs, if you like. 2 of them are mentioned here. One, I think, it can be quite interesting for you, for this audience as well. This is the European Union funded PARC project. It will start next week, in fact. And this is a project where also some of you are involved in, some of you of the panel members, I mean, where we try to extend that, that network of sudden cardiac arrest investigators even beyond what we have already. And another one is a Horizon project, which started this year. It's a profit project about risk prediction in sudden cardiac arrest in post-MI patients. The next slide, please. These are just a few examples of the papers that we have been able to publish so far. As you can see in red, the subjects are quite varied, I think. I think this is where we all try to go to, as I said, make it as broad as possible, but also try to connect both pillars that I talked about in the first slide. So we try to connect the biology of sudden cardiac arrest with the treatment, because the biology, the person factors, if you will, of course, can also impact on the chances of a person to survive resuscitation. And then the next slide. And then we have also some COVID papers. Simone is one of the authors of one of these important papers, which has been published in the European Heart Journal. So yes, as I said, we try to achieve the broadest possible scope in ESCAPE-Net. And I'd like to finish by saying that I think one of the most important things that we learned from ESCAPE-Net is that the collaboration that we have established is not only very enjoyable, truly enjoyable, but also very productive. So what I mean to say is that I very much welcome any one of you who would be interested in joining these efforts. We have a website. The name of the website is mentioned in the presentation, in the longer presentation that you can find on the ERC, the Congress website. So please do not hesitate to get in touch with us. And with this, I'd like to end this presentation. Thank you.
Thank you very much, Hanno, for this quick overview on a huge project, I can say. I have had the opportunity and the pleasure to join all the last three group meetings, always in January. And I can add that it was always a lot of energy, a lot of enthusiasm, a lot of many young people, many great ideas, many projects. And thank you very much for inviting all of us and all the attendees of this session today, for bringing in ideas and projects into your network. So thank you very much for this. And I'm just looking to my screen, and I cannot see any questions from the audience yet on my screen. I hope that this is not only a technical problem, but it's really the truth. And then I would like to ask you, maybe you can tell us a little bit. One of the major focuses of ESCAPE-Net is genomics, and that is really new, and that is really a massive new border that you are approaching, and you probably will go behind this border. What can we expect from these genomic investigations when they are ready? What is your vision? What is your speculation on this?
Yes, well, I'm very happy that you asked, Bernd, because this is indeed one of the pet elements of mine within ESCAPE-Net. So yes, first of all, I think one of the big values in the ESCAPE-Net database is the presence of big, or for cardiac arrest research, big numbers of DNA samples. This is really one of the largest DNA sample sets for this type of research worldwide. And what do we try to achieve? So we are now working both on trying to find common genetic variants, SNP analysis in the genome-wide association studies. And we will also do rare variant analysis, mutations with whole exome and whole genome sequencing. And what do we do it for? So eventually, there are several projects going on. One of the projects is, of course, to try to find the genetic susceptibility for cardiac arrest under particular circumstances. And I think one of the most clear circumstances that one can think of is the use of medications, of drugs. If I talk about the current COVID situation, there's a lot of interest in the use or not use of hydrochloroquine and of azithromycin. These are, well, azithromycin is an antibiotic, of course, and so these are not even cardiac drugs, but they can, that was the discussion, increase the risk of sudden cardiac arrest because they impact on cardiac ion channels that control cardiac electrophysiology and ECG. They can prolong the QT interval, basically. Now, this risk of sudden cardiac arrest is particularly high if you have a particular gene variant that in these ion channels. So being able upfront to identify whether or not you have such a gene variant makes it much easier to determine whether or not you can get these drugs. And now these are just two examples of drugs, but the group of drugs that is actually relevant is much wider. It also includes antihistamines, hay fever pills, very innocuous drugs. So I think we are working towards getting a pharmacogenic passport that anybody can get. I mean, really anybody, because it's also a very low cost thing. It doesn't cost much to do that. And then with that, you can go to your pharmacy and ask your pharmacist, can I actually get this drug prescription or not based on my gene profile? And so this, sorry?
Okay, thank you very much. We need to shorten a little bit the answer because yes. we are already out of time, and I was reminded by my co-chair that we all should stick to 8 minutes. So
okay, sure, of course.
Just one final question with maybe a short answer from Gavin Perkins. Great talk, thanks. Have you been able to continue to collect genetic material during COVID?
Yes.
Just one sentence, please. And then we have probably some more place for discussion at the end of this session.
Yeah, with difficulties, but yes, fortunately, yes. Yes.
Excellent. Thank you very much, Hanno. Another applause. Yeah, and I will ask Charles to take over for the next presentation, please.
Thank you, Bernd, and apologies to move things on. It'd be great to have a little bit longer from everyone, but time is our enemy. So it gives me great pleasure now to introduce Dr. Wolfgang Wetsch, who is an emergency physician from University Hospital Cologne, with an interest, and correct me if I'm wrong, in intensive care medicine and emergency medicine. And Dr. Wetsch is going to talk to us about Emergency Eye, another European Union funded project. Thank you.
Thank you very much, Charles. I'm trying to share my screen, share some presentation on a project that we have been working on, and I have also introduced it already in Freiburg. It is called Emergency Eye. It's an EIT funded project, so it was European Union funded, and I'm happy that I'm also able to show some results. Just a very short overview of how it works. Emergency Eye is a new developed software that can be installed on smartphones, and it can also be used even if it is not installed. It shortcuts the connection from an emergency caller to the dispatch center, and it will enable the dispatch center to get data that is derived from the smartphone, such as the GPS coordinates, and it will also enable the dispatcher to use the smartphone cameras to see what the caller is faced with. And I'm proud to show you 3 publications that we were able to publish this year. The first was in the European Journal of Anesthesiology. It is video-assisted cardiopulmonary resuscitation via smartphone improves quality of resuscitation. We did a simulation trial comparing unassisted CPR with telephone CPR and video CPR. And as you can see, there's a big difference in the quality between the unassisted CPR and the assisted CPRs. And you can see that there is a tendency that video CPR performs even better. The second study that we did was in a live area. So the first one was in our skills lab, and the second one was in the city of Cologne. So we used real mobile data to test the software. and we had a randomization. The dispatchers did not know what they would see, and we put some mistakes into our resuscitation algorithms that we showed. And it was very interesting that with the use of this quite low quality video stream, the dispatchers were almost able to recognize most of the mistakes shown in the 90%. It is, yeah, it's tremendous that all the bad CPR quality was recognized in almost any case. And interestingly, the only things that were not recognized so really well were if somebody was over-enthusiastic and doing too much, too high compression frequency, pushing too hard or too fast. And this may also be attributed to training, because the dispatchers are trained to motivate and not to decelerate the helpers. And my favorite publication is the last one. It came out in Resuscitation. We compared the accuracy of automatic geolocalization of a smartphone during emergency calls with a conventional one. We chose a pattern here in Cologne that is quite actual. It's not actual positions where real cardiac arrests were, but it is comparable to that was what last year happened. So we choose these 54 locations and we set up an emergency call from there, and we compared how long it takes until the dispatch center knows where the caller is, until the EMS is dispatched, until the first chest compression is applied, and we compared the difference between the actual and the estimated position. And there is you can see it is all highly significant better when doing the app-based positioning. And the biggest surprise was the difference between the actual and the estimated position, which is here more than 1 kilometer away. That comes from the fact that in Cologne, and I think the same may apply to other cities, there are street names that are once in the west and once in the east of the city, and they were in one case they were 30 kilometers away, so the dispatcher would have sent the vehicle to a completely different place where no emergency was. Yeah, that's what we published this year, and I hope that I will be able to show you some more publications next year.
Great, thank you very much. That was a virtual clap. Just while we're just sorting out any questions that can come through, can I just ask you, so is this software is free, is it, for the public to download? Is that the plan, or is it not actually live yet?
The software, we were involved in testing it. It's actually a commercial product.
Okay.
So it has to be licensed by a dispatch center, and then everybody, even if they have not installed it, can use it. But it has to be licensed. It is a commercial product.
So is the plan that it's free for the public to download? Is that right?
I'm afraid not yet.
But that in future, once it's up and running commercially, is it going to be free for the public, or would there be a charge to download it?
The public is not charged. The public is not charged. The dispatch centers will have to pay a certain fee for that, for the for the main part that is integrated in the dispatch center. And
will this be uniform across Germany, or is this just for Cologne?
Not for Cologne. It is. I think you must call it yeah, it's like an island, because there are several softwares, several other kind of softwares. So it's no, it's not uniform, unfortunately not.
So people potentially could have to download different apps, and then depending where they are, choose which app they're going to use to call in. Is that right?
Yeah, that's right. One specialty with Emergency Eye is that the persons don't have to download it. The dispatch center can send an SMS with an internet link, And some telephone providers in Germany are giving free mobile data for all those who are using this. So you don't even have to have a smartphone with data activated.
Right.
You
Right.
will get that in most parts. You will get that for free.
Perfect. That's a fantastic idea. That gets around a lot of those problems. Thank you. I'm just having to see if there are questions that have.
There are two questions in the answering and questions machine. We only have 20 seconds left, I would say. Will you install it in the dispatch center in Cologne? Is the first question, Wolfgang.
Yes, we're not affiliated with the dispatch center in Cologne. I know that they're interested in this, but that's not our decision.
Next is from Mahimi Sharan. Thank you for showing us an innovative way to assess response in cardiac arrest. Excited to see where this technology can lead to. Okay, that was not a question. Next is coming from Gavin Perkins. Just as we've called for AED accessories to work together, we need to do the same for these multiple apps. Okay, that is also not a question. So
that's true.
With this, Charles.
Thank you. That's fantastic. Thank you very much, Dr. Welch. That was very interesting indeed. Again, I'm sorry we haven't got more time, but I'm going to rapidly hand over to Bernd to move on with the program.
Okay, thank you very much. It is really not very much time, 8 minutes, isn't it? We're now coming to another great project, which is Eureka. Eureka, we all know Eureka is the European Registry on Cardiac Arrest under the umbrella of the ERC, initiated together with Professor Leo Bossart. And now we have with us Professor Jan Thorsten Gressner, who is the director of the Institute of Emergency Medicine in Kiel, Germany. He is, I would say, Mr. Eureka. He is the PI of all the Eureka studies, and he's also the lead author of the epidemiology chapter of our upcoming ERC guidelines. So Jan Thorsten, the screen is yours.
Thank you, Bernd, and I hope you can see my shared screen, is it?
Yes.
It's visible? Perfect, okay. So Bernd and the others, thank you very much for the chance to present. I think it's every year in the Erc Research Net session. So it's founded, as Bernd said, in 2013, and we are proud that the Eureka project is also older, and we have some really nice results that I like to share. And the important thing is that my computer is not doing what it wants to. Now it is doing. The background and the backbone behind Eureka is this fantastic network what we were able to establish. And you can see a lot of people, maybe some of you are also in that online session. So 28 registries in the last paper means 28 national coordinators and a lot of more than 400 local coordinators and participants that joined that Eureka idea. And we are really happy about this great network, and that gave us a chance to see what happened in Europe. And if you look at these numbers, and these are numbers from Eureka 2 studies, I don't want to look to the details of incidence of CPR, but I want to show you this great number of participants from Austria, Belgium, and all the others. And this is the first success what we can say for Eureka, and not only for the studies, that there's a network that people with long ongoing registry help each other, but also for people that establish registries only for maybe the studies, are in a network that can assist them to build a stable and robust registry in the future. 37,000 cases, one of the biggest studies ever made in Europe about cardiac arrest, 25,000 cardiac arrests, and started CPR. You can see the figures and numbers, and I think you can see it in the paper. The paper is, I think, well known, and the longer presentation will be available on the website of the ERC conference. So I want to jump to the next slide. And I think when we talk about cardiac arrest, don't look at 67.6 years as a median, but look at the next number here. It differs between 56 and 75 years. So cardiac arrest in Europe is not the same in every country. So we have the same guidelines, but we have different characteristics of our patients. So some are much younger in some areas, in other areas they are much older. So this is something we should keep in mind when we talk about CPR treatment and when we talk about results. The other thing, And this is what we discussed over the last years. And I think the COVID discussion is also very important when we look where the cardiac arrest occur, and most of them occur at home. And you can see the ROSC rate at home. You can see the survival rate at home. It's low. So it's lower than in other areas, maybe like in the streets. So we have 13%. And you can see the bystander rate differs between maybe a little bit more on the next slide, but you can see here the ROSC and the survival rate is really not the same depending on the place where you occur, where the cardiac arrest occurs. And this is one of the major slides, and I think Bernd knows the number exactly from the early century. So we have in Germany 17% 10 years ago bystander CPR rate, and what we see and what we are able to achieve, not we, but the national councils were able to achieve is a high number of really good countries with 80%, over 80% bystander CPR rate, and the mean value just is 58%, but there are still some countries lower than 20%. And if I only look at Germany, we came up in that study with 46. We started with 17% 10 years ago. So we have learned within the network from the others and had the chance to see what all these great initiatives did in our country. But not only answers came up with the study and with the network, there will be more questions. And one of the second papers what we had nearby the Eureka study was the paper from Holger Maurer here from Lübeck, when is a bystander not a bystander anymore? And we have a serious problem, I think, in Europe, and this is something what we can discuss with the experts, that bystander is more than a yes or no. And we figured out that more than 50 potential explanations for a bystander are available, and people answer in different ways. And I think this is a real serious problem when we talk about the impact on bystander CPR, and we're just talking about who is the bystander, not what is the bystander doing. So this is, I think, the aim for every network. You should have some answers, but at the end you must come up with new questions, and it's fantastic to discuss it within that group. To put it on one slide to say what are the main facts from Eureka 2, we have data from 28 countries. We have nearly 180 million people covered in that study. So 25,000 cases, what I said before, with started CPR, the bystander rate between 13 and 82%, and the ROSC rate also between 8 and 42%, and 8% of the patients were discharged live all over Europe. Not powered and not analyzed for that question, but a thing what we have also figured out and significant, the difference between the outcome and the not ROSC, because it's long-term outcome, so survival to hospital discharge, when you do CPR only, then it's much higher than if you do nothing. But if you do CPR with ventilation, we saw in that 3 months analyzed at 80%, so 4% higher, and that's a significant higher outcome. So there will be a discussion about full CPR versus CPR with hands only, but we are sure that without any treatment, people have the versus change to survive. What we did also with the Eureka network, we were able, and we are really happy and proud about that. We did it last Tuesday, that we had a worldwide collaboration with other registries. You can see PAROS, CARES, the AUSROC registries. So it was a worldwide meeting that people from all over the world were dealing with registries were able to share their knowledge and to learn from each other. And I think this is also a big point for networking as the Erc Research Net, but also at the Eureka network, to learn from the other countries. So back again to the first slide. These are the people behind, and I'm really proud that I was asked to talk about the Eureka study in this Research Net. And I say thank you for listening, and I'm happy to answer questions.
Thank you very much, Jan Thorsten. We have 7 minutes now, and we have 1 minute left for brief questions and answers. I don't have anything on my screen. Is there a question from this group? Otherwise, I would ask Jan Thorsten. Jan Thorsten, what is, in your eyes, the most important new thing that we have gathered through Eureka?
Please, Bernd, I can't understand you clear. Can you repeat that question?
Sorry, I repeated and go a little bit closer to the microphone. What is, in your eyes, the most important new thing that we knew since we have all this data from Eureka?
I think what is a very important thing is that we have, of course, the same guidance that just came out this time, but we have different situations, circumstances in every country, and within the countries there are different circumstances. So our idea of one fits all with the guidelines is the best thing we can do to train people and to treat victims. But what we saw that maybe was clear when we see the difference in age and sex and in also the circumstances, that there may be more individual treatment necessary and needed, and Eureka could be a good idea to come up with questions and show the differences, and then the rescuers and the MS and the paramedics in these countries must use that data and learn from each other. So I think it's frustrating if you think, oh, it's so different, but I think it's a chance to see that there's such a variety so we can learn from each other, and I think this was one of the big goals in Eureka 2.
There are a few questions that have come in the last minute, so I don't know how much time we'll have to answer them. But
maybe we can answer them at the end if we still have time left. But two questions I would like to cite here. Two people are asking what will be the goal of Eureka 3?
This is a really good question, and I always give the same answer as last time as you asked me after Eureka 1. I think we have two things. You have to strengthen the network. This is very important, and we should go for the idea of an ongoing registry. But I think this is something what the group will decide, the Eureka network will decide. And yes, clear answer, there will be a next study, but I think it's more important to strengthen the network and help these upcoming registries to have an ongoing system. Then we can share data, and then we can learn from each other.
Thank you very much. We have to stop this discussion. Unfortunately, now there are some further questions in the chat. Maybe try to answer them in the chat if you wish. Thank you very much again, and I would now give the microphone back to Charles.
Thank you very much, Jan Thorsten. That was very interesting. And talking of registries, we're still going to stick on the same topic for the next few minutes. So we now have Jimena del Castillo, who is an intensive care doctor, I think in pediatrics in Madrid, who is going to present some work on the International Registry of Pediatric in hospital cardiac arrest and quality of pediatric resuscitation. Thank you.
Thank you, Charles. Well, I'm afraid that my contribution is a bit more humble than those presented so far. As you have said, a pediatrician, and I gather that most of you haven't had enough time to view all the pediatric presentations in this conference, nor of reviewing all the recommendations by the ILCOR. But I'm going to drop on a spoiler. In pediatric cardiac arrest, there's not much evidence. So all the recommendations, what they say is that we have too many gaps in knowledge. This is why I want to invite you today to participate in two of our projects. The first one is the creation of an international registry of pediatric in-hospital cardiac arrest. It's written in English and Spanish, so it gives you a chance of learning another language apart from English. If you want to join it in Spanish, it focuses following the OTSTEN guidelines in gathering all CPR data from different hospital settings, and thus hopefully allowing the analysis of some of our current controversies in pediatric cardiac arrest. It will provide you a chance for taking part of manuscripts, writing groups, authorships, to any contributing author. And it gives us a chance for us, the small pediatricians, just like Joda, to look into the big adult example and have a permanent or ongoing registry of pediatric in-hospital cardiac arrest in Europe and other places, because we've invited Latin American countries too. And the second important project I'd like you to contribute to is the Pedi Rescue project. You might have read that it's aforementioned in the pediatric guidelines by the ILCOR because of its expected contribution to defining quality CPR in children. This project is under the leadership of Professor Vinay Nadkarni from the Children's Hospital of Philadelphia and his team. It's an international collaborative that looks at different phases of cardiac arrest, and just like a big brother, covers prevention, just-in-time training, the use of feedback devices and quality measurements during CPR, debriefing, and protocolizing post-resuscitational care. Up to date, 58 hospitals have already joined in from all parts of the world, mostly the USA, but there's some European hospitals, Australian and Asian hospitals too, and Latin American too. And from my own experience in taking part of this, I can tell you that it is hard work, definitely, but it pays through because it gives you a chance of being part of a wonderful and vibrant community and provides the continuous stimulus to improve your performance. You cannot get better in something you not measure, and you have to collect your data in order to improve your outcomes. So we need to join our efforts. We need you to jump in with us and become part of both our in-hospital pediatric cardiac arrest registry and the Pedi rescue. Gathering as much information as possible will enable us to get closer to bridging all these gaps in knowledge in pediatric resuscitation. And there are too many, and we have to get into this. So I'll leave you my contact details, and I'm open for any question. Just reach out, please. And thank you.
Thank you very much. That was great. And in fact, you've answered my first question in terms of putting your contact details up, so that I presume if people want to get involved with this, would you like them to contact you directly?
Yes, that'll be the easier way to reach out for both of you. Yeah, I can. Yeah. Great.
So there's been a request for you to put the link of the registry in the chat, and also the link for the Vinay Nadkarni's project, and perhaps your email address if you're happy to do that in the chat, and then people can have access to that while the meeting continues. Is that all right?
Yes, I'll do that.
Thank you. Well, I hope this has been a good recruiting platform for your very important project. Of course, the pediatric side of things is much less understood. So we look forward to perhaps at the next Congress hearing more about some of the preliminary results as they begin to evolve. Thank you.
Thank you.
Right. So if there are no more questions coming through on the chat, I think, Bernd, I might hand back to you to move on with the agenda. So, Dr. Del Castillo, thank you ever so much. That was very interesting, and we all wish you the best of luck in terms of getting this important registry up and running.
Okay, congratulations again also from my side to what you're doing in Madrid. We now have more or less spent half of the time of our session, and we have exactly now had 4 out of 8 presentations, so we are pretty much in time. And it is a great pleasure and a great honor for me to introduce now to you the next topic and speaker. The next topic is Kids Save Lives in Europe and in the World 2020. And it is probably not necessary to introduce the next speaker because we all know him very well. He's an anesthesiologist and intensivist from Bologna in Italy. He's the ERC BLS SEC co-chair. He is the lead author of the ERC guidelines chapter on systems saving lives. We already heard about that, which is a new one and a very important one. He's the former president of the Italian Resuscitation Council, and he is probably one of the fathers of Kids Save Lives, and it is no one else than Federico Semeraro. Federico, please help us with an update on Kids Save Lives in the world.
Thank you very much, Bernd, for the kind presentation. It's a very pleasure to spend some time with you. I promise 3 minutes to complete my presentation. I share my screen. Can you see?
Yes, we can see. Thank you, Federico.
Okay. So, Kids Save Life in Europe and in the world. I'm Federico Semeraro. I'm a consultant in anesthesia and intensive care from Bologna, Italy. This is my conflict of interest. As you know, you can see I must have was Star Trek addicted. Sorry for that. What is Kids Save Life? A worldwide campaign developed by Bernd Bottingen and supported by ILCO, ERC, and other international society, and also by WHO. The Professor Bottingen is the nice man with a red balloon on the left. And we published several articles about Kids Save Life campaign in Europe in 2016 and in 2018. Unfortunately, recently, COVID-19 affected Kids Save Life implementation, but we believe that kids learn much better than adults the new rules of the game for CPR training in the COVID-19 area. And we published this letter to editor to invite all the communities that must overcome the fear of COVID-19 to help kids to learn to save life in this period of time. We also update the European CPR Training Map for the new guideline. Thank you to Resuscitation Council UK and Charles and Andy Loki, because we have a new United Kingdom in red on the map. We are very proud of it. And we have a dream to complete this map that become red and pink, and we are very proud of it. So, a lot of amazing awareness campaign all over the world for the World Start a Heart. There is a strong connection between World Start a Heart and Kids Save Life in Europe and outside Europe. So we started to collect information about Kids Save Life outside Europe through the World Start a Heart Day network. We started in January, and this survey was obviously affected by COVID-19, but we have some data. As you can see, we have some Kids Save Life ambassador very active in Brazil, South Africa, New Zealand, in Saudi Arabia, in Sri Lanka, and school children training is suggested in India, Sri Lanka, in Canada. And as you can see in US, we have a lot of states where the school children training, it is a law. So this is my backstage for today. My take-home message, please spread the word about Kids Save Life campaign and wear a mask, stay far away, and wash your hands. Thank you very much indeed.
Thanks, Federico, for this. You have saved us a lot of time with your enthusiastic presentation. I do not see questions in Slido right now. So I'm looking around in the group of presenters and moderators today. Are there any questions in our group to Federico? Otherwise, Federico, I would like to ask you, what are your 3 most important wishes for the future of Kids Save Lives all over the world?
First, that COVID-19 finish as soon as possible. Second, that we restart the Kids Save Life campaign all over the world as soon as possible. Third, that adults learn the new rules of the game for the kids, because they are much skilled than adults to wear the mask, wash the hand, and apply the social distancing. This is my 3 wishes for the future.
I would like to add, we have seen from Eureka, from Jan Thorsten, that the survival rate, if you have a cardiac arrest at home, is not so good as if you have it in other places. That is another argument for bringing these Kids Save Lives campaign into the whole world, because then we can get the knowledge into the families if we ask the kids to teach their parents, grandparents, and many others. And Jan Thorsten has a question or a comment.
A comment, Bernd. Yes, you're right. And if you see the family, if there's a young person that can do CPR, then we have a chance that the bystander rate is higher at home. What we saw in a subgroup analysis in Eureka 2 is that normally the bystander is more or less 5 years older or younger than the patient. So we have a great chance for the youngest, but we should not forget the older ones. So the training must be in any age area. And I think we can maybe copy Kids Save Lives to OPAs and OMAs Can Save Lives due to the fact that this is a group of our main patients.
Thank you very much, Jan Thorsten. We have a question now from Michael Baubin. Arguments for management of Kids Save Lives in school under COVID pandemic, Federico.
It is easy for me to suggest virtual reality, e-learning, and all the new technology for CPR training is the only way at the moment to transfer some information and knowledge to the new generation.
Okay. No further questions in Slido. Well, maybe one final question from my side. When to start? Immediately after birth or in the kindergarten, or what would you suggest?
We can start very soon. If you think about our project by Italian Education Council, we develop a tale called A Breathtaking Picnic that we use it in kindergarten. So we can teach and learn to recognize cardiac arrest very early, much earlier than 12 years old. So we can use in a primary school, so we can use in high school some serious game as lifesavers, some virtual reality CPR. So we can spread the word of Kids Save Life campaign from the kindergarten to the high school with obviously different tone of voice, I can say.
Okay, thank you very much. We now spend 7 minutes on that topic, so we still have 1 minute, I would say, if we like. Any further questions coming? Oh no, they are coming in. From Anastasis Stefanakis from Greece about Kids Save Lives campaign. Federico, in what age do you suggest to start educate them? This has probably already been answered. In Greece, we train them from 10 and older, and they are great. Well, that's more a comment.
As you know, many of Kids Save Life fans know Emmy de Bach published some years ago a very nice article about the educational pathway in relation to the school children and age. So I think we can start very soon in the kindergarten to recognize a patient that collapsed, call EMS. And after, we can also start to teach CPR, the 12 years old, because at 12 years old, you have the strength to have a good CPR, but why not at 10? Why not at 8? CPR, some CPR is better than nothing, obviously, but at 12, obviously is correlated with BMI. If you have a very big 8 years old German boy, I think we can start also earlier.
Comment from Naomi in Brazil. We have performed Kids Save Lives program in Brazil with people from 3 years until 91 years with different approaches, as you pointed out. So obviously all this works. And I have a final question to you, dear Federico, from Jan Breckwold. Dear Federico, what do you suggest to answer to school authorities if they don't want to introduce mandatory training, ? Please, brief answer.
Yeah, there are a lot of nations in Europe and in all over the world that apply a law as for school children. So we need only to give them an example of implementation. We have several examples with several success. And politicians need a lot of photos, so we can promise them a lot of photo, a successful photo after the law will be implemented in their country.
Okay, thank you, Federico. Because of time, we need to end this discussion. Now there are 2 or 3 further questions for you on the screen. Maybe you can answer them by email or so, or at the end of this session. Thanks again, and some applause, and I will get the microphone to Charles again, please. Charles.
Thank you, Bernd. Well, that was very interesting. And again, I'm sorry we don't have more time to discuss some of these things, but moving swiftly on, it gives me great pleasure to introduce Andrea Scapigliati, who I'm sure is known to most of you. Andrea is an intensive care physician in the beautiful city of Milan. I'm very envious. And Andrea, am I right in thinking you're also the chair of the Italian Resuscitation Council? Is that correct? Sorry, I think you're still on mute, Andrea.
Here we are. Can you hear me now?
Yes, we can now, yes.
Yes. Thank you very much, Charles, for the commitment in pronouncing my family name in a good way.
Thank you, that's very kind of you.
Not a simple job. And yes, I was a chair of Italian Resuscitation Council, but I would like to thank you for the opportunity to present this project and the opportunity to see you all smiling, at least during this session, despite the hard time we are going across. Let me present you this new experience for me, for us, from Italian Resuscitation Council. That is a new project, a new European project, as well as most of those that we addressed so far. Is a coordination and support action fund by the European Commission within the H2020 framework. And this project is quite new for me, as I was saying, because it's a project about emergency medical service across Europe. As we heard so far from many other researchers and experience and projects, cooperation is one of the most things to achieve innovation and to achieve new targets. So this project has the main objective to facilitate strategic partnership among all those involved in emergency medical service in Europe, identifying challenges, stimulating uptake in order to standardize what we are doing in EMS in Europe, and with the specific purpose to deliver technical requirements for procurements in Europe and for countries in Europe that need to improve their service on the field. Who is this project? Is a consortium compounded by at least 7 countries that you can see listed here, with a coordinator that is senior based in Austria. And there are partners coming from many countries in Europe, and we as an Italian Resuscitation Council participate as the Italian side of the project. And the project has had so far several phases, and was able to contact, to engage directly practitioners, organizations, and to organize workshop, webinars, and survey, by which the project was able to identify, to collect a lot of needs and challenges coming from those that are working on the field in the EMS systems. Of course, a selection process was needed to collect and to identify the main areas to work on, and a top list of priorities emerged with these 5 main areas that you can see here: training, treatment, triage, bystanders, and emergency call centers. As you can see, there are a lot of connection with previous programs and projects that we heard about in this very interesting session. Probably due to the pressure induced by the COVID pandemic, the triage area was identified as the most urgent area to be addressed, and especially because there is, and as you probably know and face with, we need a standardization, especially to quick and accurate overview casualties or people affected by other pathologies. We need a system that is able to support decision, to improve interoperability with every other kind of responders, including, as Wolfgang showed us, the first responders, a system that facilitates handover and reducing time and can give us insights for quality assurance and training measures. So whoever is interested in this project, that this is still ongoing, so I haven't so far any other data to present to you, but please, everyone who is interested to participate, to give his or her insights to this kind of investigation, please is very welcome on the information hub hosted on the website of the project. And please save the date, because on the 3rd of December 2020, we will have the virtual final event in which the project will be presented with these achievements, final achievements and results. Thank you very much for your attention.
Andrea, thank you. That was great. Obviously, a huge amount of work there, summarized in a very short period of time. But there's clearly been some very interesting aspects of our work that you've identified there. Do you want to just, on the chat, do you want to put the most appropriate contact details in the chat as well? I know you've mentioned
yes,
it tonight, but for the audience, it might be the easiest way. In terms of linking up with people who want to get in.
Yes, I will copy and paste on the chat, so you can.
Just while we wait for any questions to come in, how you've identified quite a lot of problems and areas that we need to prioritize. How do you see that moving forward in terms of being translated into solutions? What is your next step in this process?
Very good question. What I'm learning from this project is that it appears that the medical system is one of the systems in which technology and innovation is less implemented compared to other kind of areas. So probably we need to understand which kind of technology, which kind of innovation, which kind of new solution is able to solve all the problems we are dealing with, especially in this moment. The fact that triage was identified as the most important and urgent area to work on is probably due to the fact that when there is a crisis, when there is a overload of requests compared to resources, we need to identify our priorities. So my message, what I'm learning from this project and from working on this project, is that we have to learn how to implement and to discover new technologies, or how technology that already exist can be implemented and imported in our daily work.
Thank you, Andrea. That's great. Well, perhaps at the next Congress in a year's time or so, we may get you to come back and tell us the latest.
I hope so. I hope so. And I hope that in the next Congress we will be in person and we will speak face to face.
Absolutely. Absolutely. I look forward to it very much. Well, thank you very much. I can't see any other immediate questions coming through. So in the interest of time, we'll thank you once more. and hand back to Bernd.
Thank you very much, Andrea and Charles. We have 27 minutes left, and we have the next presentation on post-cardiac arrest prognostication, and it's coming from Yasmin Taleb, and I would like to introduce her as an enthusiastic young researcher from Egypt. Yasmin is a lecturer of forensic medicine and clinical toxicology of the Faculty of Medicine of the Mansour University in Egypt. She's currently in Heidelberg in Germany, and she is a very enthusiastic supporter from Erc Research Net. So Yasmin, we are looking very much forward to your presentation.
Thank you so much, Bernd. I'm so happy. It's my pleasure to meet you all, despite all the chaos all over the world because of COVID-19. Thanks for the modern age technology. I'm gonna share my screen. Okay.
We can see it now. Thank you.
Okay, it's possible now? Okay.
Perfect.
Okay, so I'm gonna go directly to my topic today, which is the post-cardiac arrest prognostication. I'm gonna focus on the microRNAs as a novel biomarkers and plausible therapeutic targets after cardiac arrest. I would say I'm so impressed with the much publication I see today in this session. I would say myself is still in the infancy, but still I'm enthusiastic. Let me start with one simple question: why we prognosticate, why we need this kind of prognostication. Actually, we need to prognosticate because we need to take decisions in the clinical setting, in the clinical practice. And this decision would make us able to continue on the management of care for our cardiac arrest patient at early stage after cardiac arrest. We could change overall management, or ultimately we could withdraw care. But unfortunately, with all kinds of resuscitation effort and even with return of cardiac return of a spontaneous circulation, we still have these unfavorable neurological and cardiac outcome, which is the post-cardiac arrest syndrome. And till the moment, with all studies and researches in the field, we still don't have a single or group of factors that can predict the outcome after cardiac arrest, and especially after the early stages of the cardiac arrest. There is a lot actually of biomarkers that is already used. Actually, I would say in the term of research, there is a lot. Some are released primarily in the brain and then into the circulation. So it passes first into the CSF and then into the circulation. Some are released after cardiac injuries, which is most commonly the troponin, and some are in the peripheral circulation directly, like the pro-inflammatory biomarkers, interleukins, and procalcitonin, which all of them used in the clinical setting as well. And they aggravate and exaggerate the sepsis-like syndrome. In the last year in the ERC Congress, we present another panel. This was my poster presentation actually, which is the the endoplasmic reticulum stress-mediated apoptosis biomarkers, like some proteins. One of them, which is most commonly frequently encountered, was PERK expression, together with the neuroinflammatory and the other cytokines, which is already known, like interleukin 6 and 8. This was an animal experiment done on mouse, and it was high level of these biomarkers, which leads to unfavorable neurological outcome. The gap knowledge, why we built our new research or why we built our new project. Actually, the problem is many confounders that prevent us from a meaningful way of interpreting that data from different prognostication biomarkers, which is already in the market, if I can say this. These are related to the patients, related to the heterogeneity of the cardiac arrest situation, population, and effort treatment, and so on. The second factor actually is the influence of the blood-brain barrier. And to make this very simple, we have two most frequently encountered biomarkers, which is the S100B and the neuron-specific enolase. These two biomarkers are increased or released into the brain and then into the circulation. They are cleared differently from the brain into the circulation. And there is other routes that trigger their release into the circulation. For example, this kind of lymphatic system. This is also a lag of time from the time released into the CSF and then into the blood. Finally, neither are brain specific. So we cannot say that they are specific for the brain injuries or they are not specific as well for the cardiac arrest. So that's why we still need a novel biomarker. And the main question we pose here is how those brain-enriched proteins leave the injured brain into the circulation. And why we need this? We need this for better understanding of the pathophysiological, what's pathophysiologically inside the brain happened after cardiac arrest. And we need this for the clinical setting for better and improved utility of the biomarkers in the clinical setting. And for that, the novel biomarker we focused on is the microRNAs. We are still in the very first stage, so we have one publication discussing the microRNA expression profile as a mechanism for diseases development, and we use the human tissue, post-mortem human brain tissue. We optimize the condition that we have a good quality of result from those tissues, and how can we start the proteins, how can we start the DNA leads, how can we study as well the RNA yield from the post-mortem human brain tissues. This is our two publications, and the take-home message: we still need to bridge the gap between the basic research and the clinical practice for the better use of this. Thank you so much for listening.
Thank you very much, Yasmin, for this great overview on your work and on the whole problem. This is a very tough area. I know we did some research on S100 in patients several years ago. Congratulations to this. I'm just looking in the screen. There's a question from Naomi coming in from Brazil. Yasmin, please. The blood collections were performed in the same day or period after sudden cardiac arrest and resuscitation. How many people and from how many institutions is the question for you?
One more time, because I couldn't hear this question as well.
Yeah, we'll try again. From Naomi in Brazil. Yasmin, please, the blood collections were performed in the same day or period after sudden cardiac arrest and resuscitation. How many people and from how many institutions?
Yes, we have 20 cases. We examined 20 different brain regions. The cases, the specimen was collected just directly after death, just directly after resuscitation. It was kept in formalin for 1 day, although normally we need to keep them in formalin for 2 weeks, but we did this like a fresh cutting of the brain region post-mortem, and some other samples are freshly prepared in a liquid nitrogen and then into freezing. So 20 cases, 20 different brain regions.
Thank you very much, Yasmin. The time is over. Thanks for all your great work and enthusiasm. And
you are so welcome. Thank you.
Good luck for the future. And the microphone is getting to Charles, please.
Yeah.
Thank you, Bernd. Thank you, everyone. Our penultimate speaker is Dr. Simone Savastano. It gives me great pleasure to welcome you. And Dr. Savastano is an interventional electrophysiologist from Pavia in Italy. And he has a special interest in cardiac arrhythmias, particularly I think cardiac arrest and VF. We're going to hear from him about some recent insights from 3 big studies: PEACE study, the ENSURE study, and the Thunder studies. Thank you.
Thank you very much for your kind introduction, and thank you, Bern, for your kind invitation. I'm sharing the screen. Okay.
Looks good.
Okay, thank you very much. Let's get started. So, in the coming minutes, I will speak to you about the PEACE study, the ENSURE study, and the Thunder study. For what concerns the PEACE study, we all know that the 12 leads electrocardiogram after ROSC plays a pivotal role in the diagnostic step after cardiac arrest by disclosing cardiac ischemia, underlying cardiac arrest. But in the real world, the situation is sometimes tricky. Let's take a look, for example, to these 2 electrocardiograms. So in the first case, we can all easily know ST segment elevation, and so the patient probably would be a good candidate for an urgent coronary angiography. And in the second case, we can see an ECG that looks like normal. So here, in the second case, probably there is no indication for an urgent coronary angiography. But I will surprise you by saying that the patient is the same, and his coronary artery were absolutely normal. So what is the difference between the 2 electrocardiograms is basically the time passed from ROSC to acquisition of the ECG. So if you have to decide after this ECG, you probably take a decision. On the contrary, if you have to decide after seeing this ECG, probably you take another decision. So time probably is really the matter. So we designed a retrospective multicenter international study involving Pavia, Vienna, and Lugano. And every ECG, every post-ROSC electrocardiogram has been carefully evaluated and categorized as positive or negative for ST segment elevation myocardial infarction. And we looked for a correspondence with the coronary angiography of the patient. The result is that we have analyzed more than 500 ECG, and the results are very, very interesting, but unfortunately I can't share in detail with you because they have been submitted to JAMA Open Network, and we currently handling the reviewers' comment. But I can anticipate to you that the time really matters, and the sooner you acquire an ECG, the higher is the probability to have a false positive. It is to say, to have an ECG positive for STEMI, but with normal coronary angiography. So I hope you will read the result very soon. So let's move to the ENSURE study. So we all know that the AED is a very easy and life-saving device, as we highlighted in our very recent review, but we know also that the rate of defibrillation, of late defibrillation, is very low and variable from country to country. So with the ENSURE study, we would like to take a picture of the late defibrillation across Europe. We have a survey, but the last survey in Europe was published more than 10 years ago. So the primary endpoint of the ENSURE study is to estimate the rate of AED use by lay rescuers before EMS arrival. And as a secondary endpoint, we have the correlation between the number of AED spread in the territory and the rate of lay defibrillation. Interestingly, we would like to explore also the relationship between the AED use and the law running in each country. So basically, we design an online questionnaire, and here we can see the link that was shared among the national investigators of Eureka in order to have to answer some very easy questions. It takes more or less 10 minutes to fill the questionnaire. So many have already answered the questionnaire. Some of them not yet. So please, if you have interested, please get in touch with us by mailing to me or to Dr. Baldi. These are the countries that have already filled the questionnaires, but some other are still missing. So the state of the study is that it is currently enrolling, and we wish to have final result very soon. The last study I'm gonna speak to you is the Thunder study, and this study is focused on intraosseous access. We know that guidelines recommend IO access in case of challenging vascular access. We know that there are some evidences showing that IO was associated with lower rate of ROSC, but of similar survival. We know that tibial access is the access of choice since it's easier and faster, but there is no clear recommendation from guidelines. Probably the site of IO insertion is still a gap of knowledge. We have some data about vasopressors, but we have strong data about the effectiveness of antiarrhythmic drugs administered via IO. We have some data from the trial comparing amiodarone versus lidocaine versus placebo, showing that probably IO amiodarone was less effective than IV amiodarone. Probably because amiodarone is a very lipophilic molecule, and the different composition of bone marrow comparing tibial versus humerus may play a role. So we designed the Thunder study with a primary endpoint of non-inferiority of tibial and humeral access compared to standard intravenous access in terms of ROSC. The second endpoint is to compare the duration of resuscitation in the three groups and to compare the number of shock delivered during resuscitation in the three groups. The design of the study is an observational study. Our idea is to plan a non-inferiority design, but if we will able to have a great amount of patients, probably we also be able to test superiority. Only shockable cardiac arrest are considered because we want to test the effectiveness of amiodarone, and Eustain variables are corrected. The three groups will be the IV line, the tibial IO line, and the humeral IO line. We are ready to go, and if you are interested to be part of the study, please get in touch with us by mailing to me or to Dr. Baldi. And I hope to have used and to have spared some minutes, and so I thank you for your kind attention, and greetings from Pavia. Thank you very much.
Thank you very much, Simon. That was very interesting. There's obviously a lot to get over to us in a relatively short period of time. Michael Bobin has submitted a question just asking, I think, with regards to the PEACE study, and how often we should be taking 12-lead ECGs in these patients, and questioning whether it should be every 15 minutes after ROSC.
So the message that probably came out from guidelines is to take an ECG as soon as possible. However, as I have shown to you, if you take an ECG very soon after ROSC, you see also ST segment elevation that is due to the cardiac arrest more than a coronary disease. So our data show that probably it's better to wait at least 10 minutes after ROSC in order to have 10 minutes of good perfusion and good circulation. Then you can take the ECG.
And you mentioned the rates of false positive ECGs, although obviously we yet have to see the results. But would you agree that the rates of false negative are just as important? Because would it not be those patients who may miss out going to the cath lab to have their coroner's image?
Yeah, that's a good question. False negative is really an issue, but we were focused on urgent coronary angiography. So I personally think that every patient after cardiac arrest should undergo a coronary angiography, at least another cause. But the key message is whether candidate for an urgent coronary angiography or a delayed coronary angiography, because we have data that urgent coronary angiography positively affect survival only in case of ST segment elevation myocardial infarction.
Okay, all right, thank you. That's very interesting. Well, we look forward to seeing all those results of the case study and the others in due course. Thank you.
Thank you.
Let me just see if there are any more questions. There's a question from Jan Breckwald asking, with regards to the Thunder study, how many patients you plan to enroll?
The highest as possible.
Okay.
So each of you with data from a Houston-based cardiac arrest registry is pleased to contact us or mailing us in order to be part of the study. Yeah.
Great. Okay. Thank you. Well, as much as we'd love to talk to you for a lot longer, in the interest of time, I will hand back to Bernd, and thank you very much again for a fascinating talk. Thank you.
Thank you.
Thank you very much, and congratulations again. And it's my great pleasure to, last not least, in this very exciting session, to introduce Tino Greif on ERC studies on education. Tino is an anesthesiologist from Bern in Switzerland. He's the ILCOR Task Force Chair on Education, and he is also the ERC Task Force Chair on Education, member of the board of ERC, many other things. So Tino, it's up to you now.
Yeah, thanks for the invitation and for giving me 5 minutes to talk about education. I will do this as fast as possible. So you see now my screen, and I go directly into the topic. I took some points from the current guidelines we wrote up, and you can see the draft on the internet. What are the problems in education? Where can you go if you want to study things? So I have 2 slides of this, and then I show you some example of already published stuff in the Erc Research Net. Overall, we still need more and better data on the high quality training. So how can we transport high quality training to high quality performance wherever cardiac arrest happens? And again, and this is maybe the most important question for me in education, does all this really lead to improved patient outcome? So all our activities at the end, do more people survive? This is one of the most important things in education. Another point which came even out of an ILCOR evidence update, we still don't know, we know for a long time that the knowledge, the competences decay, but we still don't know how often, in which frequency do we need refresher updating these competences. So this is a very important point to look at. And another point, we are teaching overall very general courses or interventions, but people are quite different, and there are a lot of different patient groups or even provider groups, people out there. If I imagine if you want to teach basic life support to a group of motorcycle enthusiasts, this has to be different from a kids' life school teaching for kindergarten. Another area we have to look much more is the training and the support of our teaching staff. Are we doing there a good job? Could this be done better with more efficiency? And also a part, we are talking a lot about human factors now in medicine. What's about the reduction of emotional and psychological trauma for the rescuer? How can we implement this in our courses? And this goes also into the area of human factor, the best way of teaching leadership and team performance. This is already a part in our advanced life support courses, but we still don't know what would be the best educational approach. In the meantime, we also have studies showing that there's a difference how women and men lead such CPR teams, and we have to address this. This is also for the refresher courses, for the people who are doing this quite long time. We need to look in the assessment, a lot of ideas about a formative, continuous assessment, and of course assessment, what really shows us the competence of the provider then on the street improving patient outcome. The value of simulation, fidelity of the mannequins, how to teach these skills is an important issue, and there are a lot of open questions. This goes also in blended learning. We are not having courses only reading or an instructor telling stories. We try to find the best way, but what's the best mix, and specifically looking at cost effectiveness, and maybe these blended teaching courses can also reduce face-to-face time. Very important nowadays. There were a lot of questions. How can we teach this in time of COVID? An area which we did not really touch in the past, interprofessional learning and teaching. At the moment, this happens, but not in a structured way. And finally, a totally open and huge discussion, which is the best way of giving feedback in our courses. And the last point here, how can we transport the learned feedback in the courses to the real clinical practice? So how can we transport feedback from our courses to clinical practice for clinical debriefing after each case? Because we know in the meantime, if this clinical debriefing after resuscitation happens, at the end or the long run, this improves patient outcome. Very shortly, some examples of studies published. You hear this about Kid Saves Life. There was a position statement how school teachers have to be taught. We know how we can teach. Here another publication about teaching children, another publication that we should not forget with Kid Saves Lives, that also at higher education, we have to teach all the students. In my point of view, every student in a university, in a school of nurses or physiotherapists, they have to learn basic life support as a minimum, and in healthcare, they should go for at least intermediate life support courses. We have some studies on human factors. Here one looking at factors impairing or engaging first responders in the actions. And another study very recently, 40 minutes of hands-on training to teach school children. Last slide from my side, a very nice study from a doctoral student of mine. She looked at different assessing methods on what we are teaching in our advanced life support course. So the teacher, the leader quality, how can we assess this? And maybe in the ERC courses, we have to adopt other methods to look at this. And with this, I stop my presentation, and I thank for your attention. That's all what I had for education. And I'm sorry that we are running 2 minutes late.
Thank you very much, Tino. We are all responsible for the 2 minutes late, and I would like to give you the opportunity to answer one question coming from Wiebe de Vries. Tino,
I can't hear you very well. Sorry.
Sorry. We are all responsible for being about 2 minutes late. So thank you very much, Tino, for this very fast track through education. There's a question coming from Wiebe de Vries. Tino, are these topics discussed with the editors of Resuscitation?
This is out of the chapter, and the chapter is a proposal at the moment. So everybody of you can comment and bring stuff in. This is the result out of the ILCOR process, and what the writing group of thinking are areas we have to look into and improve education. So I can tell you the editor of Resuscitation read these chapters and they did a review. on this chapter, so they know what's in there. And so far on this part of the chapters, there were very little comments.
Okay, thank you very much. There are some compliments from Naomi from Brazil coming in for you. You can read them in the chat and in the question and answers, transparent to everyone. So thank you very much again, Tino, and thank you very much to all of you. 9 talks in 90 minutes. This is some kind of rapid fire session. I'm very thankful for this. I'm proud about ERC Research Net. We are a great group, and we have seen a lot of activities today, and there is a lot of activities beyond. So the ERC Research Net has been developed extremely well. Please network also in the future. And the final words for today will go to Charles Deacon. Charles, if you like, close this session. Thanks to all.
And thank you. Well, yeah, I'd just like to reiterate Bernd's words. I think that was a fantastic session, and thank you all for keeping to time. The thing that struck me with the research network is that all the presentations are delivering really high quality research, which is all going to feed directly into the guidelines. So they will all make very positive contributions in terms of patient care and patient outcome. And of course, that's exactly what this is all about. So I'm very humbled to be chairing a session with such great researchers, and that has made such a huge difference and will continue clearly to make such a huge difference to improving the care of patients suffering from cardiac arrest in Europe. So thank you again, and hopefully see you all in person next year. Thank you.
Bye-bye. See you. Stay healthy.
Live long and prosper to everybody.
At Laudal, we believe in helping save lives. It's our goal to help save 1 million lives every year by 2030. We'll do this by focusing on early interventions with high life-saving potential, and by enabling technologies to reduce the quality gap from learning to patient outcomes. But we know we can't do it alone. It's through our active partnerships that we can have the greatest impact. We deliver products and programs and cutting-edge technology. But our products and programs don't save lives. People do. We help healthcare providers to be competent and confident. We're more than 1,600 people in 25 countries working towards a common mission. Our mission is helping save lives, one life at a time.